I'm sure if you've done any amount of security research on smart contracts and you've found your first couple of high findings, perhaps you've come across something that you thought, hey, this could probably occur elsewhere. And maybe you had the idea to maybe, go and search around at similar protocols, look at their code bases to see if this type of vulnerability also presents itself there. But maybe you found that the tooling to do such a thing is really lacking. And if you wanted to, really, manually have to go to each of these projects' GitHubs or use some kind of verified smart contract scan on a blockchain explorer that, does allow you to grep stuff and actually find useful things, but maybe doesn't give you the filtering and the versatility that you're looking for and that you really need when you're going to and trying to pick apart more advanced concepts for bugs and vulnerabilities that might occur in smart contracts. So today I've been lucky enough to be able to try out a promising new tool that actually addresses this and gives what I think is going to be a really cool, ultimately probably a paradigm shifting technology that I think a lot of interesting applications can be built on top of. And ultimately, immediately in the near term, will probably result in a number of vulnerability disclosures that otherwise would not have been able to be made without the necessary technology here. So what is this tool that I'm talking about? What is this tool we're going to look at today? It is Remedy. It is specifically Glider from Hexens. Now, what Glider is and what it purports to do is basically allow you to search and perform advanced queries over all of the verified smart contract code, literally the solidity code on ultimately in the future, any blockchain network that is, of course, EVM compatible and uses solidity. So today I'm going to go ahead and I'm actually going to try it out. We're going to write some queries together. We're going to figure out how can you use this thing, see how user friendly it is, see how powerful it is, how much we could actually use this thing to find useful things, useful vulnerabilities. We'll see if we can actually find anything that is of merit. And then maybe I'll talk a little bit about what I think this kind of technology could be useful for and what it can solve in the future for the Web3 ecosystem. So we'll dive in just a second. But first of all, of course, my name is Owen. Around 2.5 years ago, I co-founded Guardian Audits. Ever since then, our team at Guardian has uncovered multiple hundreds of high and critical vulnerabilities across hundreds and hundreds of smart contracts that we've reviewed in security reviews for some of the most targeted protocols in the space, namely GMX, Synthetics, Orderly Network, Dolomite, Poolshark. The list goes on and on. And the goal with all these videos that I put out, and especially this one, is to basically share all of the experience and knowledge that personally I've had, but also that our team has had at Guardian in all of the security reviews that we've done and all of the security research and all of the security operational research that we've put in and disseminate it to everybody so that ultimately, transparently, you become an excellent security researcher on your own. And one day you'll want to ultimately join the Guardian team and help us in our mission to pave the way for ubiquitous DeFi, void of exploit and vulnerabilities. Or on the other hand, of course, if you're a protocol or a developer, hopefully one day you can, first of all, implement all these things that we talked about and then come to Guardian and get an engagement and have it be a lot more effective because you've already implemented a lot of the security best practices and stuff that we talk about here. So without further ado, let's have a look at what Hexens has been cooking up with Glider. All right, excellent. And we can see I've got the Glider interface pulled up here. First thing you'll notice is that we've got some sample queries here on the left-hand side where this is really just demonstrating what Glider is. It's basically, I mean, I guess I would think of it as essentially a Python package with an interface over it that allows you to interface and make these queries in real time on the web app here. But we're on the Glider web app, and we can see that this is what the query interface looks like. It's a Pythonic interface. We can see, at first glance, what's going on here. We're getting, functions where seemingly filtering down on these with this with one property thing going on here. So functions with one of these properties, whether external or public. So external and public functions that don't have modifiers. That is not the constructor. And then we're filtering down to the instructions within a function. And we're getting self-destruct. So here we can see that basically we are grepping the entire blockchain and checking for instances of public callable functions that anybody can call that have self-destruct executed in them. So you could just call it and then self-destruct the contract and then presumably send the ether to yourself or somewhere else. Yeah, just bad stuff. Not not a very high level of security, but grepping for these kinds of contracts. And then we're doing here some, additional, since it's literally in Python, you can actually go ahead and write, like based on these instructions that have been received, we can go ahead and decide certain things, put in specific logic, and then we can see we're just returning a list of them. And then it appears that the list here is what ultimately gets displayed on the right. So this is the interface. What you do is, what I've figured out thus far. I haven't had any assistance from the Hexens team to understand how to use this. So all of this is my interpretation of how this web app works and what this product is doing. But you go ahead and you just hit run, and then it's going to go ahead and run this query. Now I'm on the Kovan testnet right now. So we're running this query on the Kovan testnet. It's going to go and basically, from the way I envision this, is they've got all of the source code that's been verified on Kovan in a database, probably a really expensive one, and we're just able to interface with it and make these queries against what is in that database. And then we can see just now, we've gotten the result, and we can see these nice responses here. We've got the contract, we've got the address of the contract, the name of it, and we've got a little snippet here of where the offender occurs. So we can see here we've got, just a kill function, erase wallet function. That's scary. Okay. Yeah, just destroy a whole bunch of just scary functions. So once again, this is on a testnet. We could go to Ethereum mainnet and run this, but I think, for some reason, getting a server error. So obviously there's the first piece of feedback, I guess, is to make the main network without a server error. But once again, I think right here you can see it's in beta, so there's going to be a lot of bugs, but I'll just be working around those for now. But yeah, so this is my overall understanding of what's going on here, what this web app is useful for. Again, I've only used it for probably just a handful of hours, just playing around with it and reading the documentation just a little bit. So we're going to do more of that today. We're going to go ahead and explore. We're going to try and write some queries. I have some ideas for some things I want to look for, and you guys are going to look for them with me, and we'll see if we can get anything interesting out of this, and we'll see how we can use the documentation. I've got the documentation also pulled up here. So here they're just describing pretty much what we've already gone through. The most interesting and useful section that I found is this API section, which just includes, first of all, just some high level notes on, what the syntax looks like for filtering down on these, and then actually goes ahead and lists all the different functions that you can call for, like, example, let's say variables. So if I want to get all variables, then I would do just, variables.exec, and this would just, from what I understand, go ahead and grab the first 5 variables that are indexed. I don't know what, based off of what the ordering would be, but just grab the first 5 of those. And then, you can additionally have like variables that have this name, and then you'll get a list of those. And then on individual variables, there's, these functions here to give you like, what's the name, properties of the variable. I'm not actually sure what that would return. Maybe it wouldn't be the type. I don't know what the properties would return. Yeah, not sure about that. Get a getter function for the variables. Is it constant? Is it immutable? So on and so forth. Now, one thing I'll say about the documentation is it seems like maybe I'm just not looking in the right place or not reading it correctly, and that's probably more likely the case. But it seems like there's some functions that are not in the documentation, at least at the time of recording this, or maybe I don't know if it's the documentation that's outdated, or maybe it hasn't been updated to the latest for the documentation. But and we'll see what that some of those functions are as we go ahead and work through this. But what I want to do, and I want to jump into it right now, is let's go ahead and find some actual vulnerable pieces of code, albeit on the Covin testnet, since we can't do the Go Early testnet yet, and then not Rankeby, and then of course Ethereum mainnet needs a little bit of, I don't know, maybe it's just not available at this time. But so what I'm going to do is we're going to create a new query. And the first one I want to look for is probably my favorite bug, since I actually stumbled across it. I think other people may have, well, definitely somebody had known about this earlier, but I stumbled across it when I was doing, I think it was probably the third security review we did for GMX v2, was that when you have blacklisted addresses, so like an address that is blacklisted for, let's say, USDC, and you try to perform a liquidation, and that liquidation function would attempt to transfer USDC to this blacklisted address, then the liquidation would revert and it would not work. And of course, that is a critical issue because we need liquidations to be able to work. We need them to be able to close out positions that are in a bad state. And if you can't do that because of some sort of DOS, that's a big deal. So I'm going to make a liquidation DOS file here, and we're going to do import, no, we're going to do from glider import star, the top of every one of these, def query, and we're going to try and find some instances of a liquidation function that transfers USDC or some token that has a blacklist to an address that is not the person who is literally calling the liquidate function, because then you can DOS based upon that. So let us first, I'm going to try to remember off the top of my head the syntax, but we're probably going to go back to the documentation. But the syntax it's somewhat discoverable. I think I do wish the documentation was just, I don't know, a little bit easier to traverse, or yeah, we'll see. But what we'll do is we'll say, let's say suspect functions. So ultimately we're gonna get a list of the functions that are suspect to this attack, potentially vulnerable to this attack, or this little bit of a bug. We're gonna do that by first getting all functions and then filtering down on them. So the first filter I'm gonna do is we want the name of the function to indicate that it's a function actually to be used with liquidation. So we could just go with name and then put liquidate in here, but I believe there's a prefix function. So sometimes the liquidate function might be called liquidate position, right? So we might want to get that, just that prefix. So a function that has a prefix. So let's see, and I'm not remembering exactly how it is, but there is autocomplete on here. So but I don't know why that's not coming up right now for me. So I'm gonna refresh this and then we'll see if we can, here we go, with name prefix. So I'm gonna try this one. And I don't know if this is like in the doc though. This is the one thing that I'm talking about. Like some of the functions here are not here. With name, so that's, okay. Yes, that's what I'm talking about. Just a little bit of an inconsistency there that would make it, a little bit nicer to be able to discover these functions. But again, it's in beta, and there's, an immense amount of work that will be done on this. But that's something that would be nice. So with name prefix liquidation, let's go ahead and let's just try to get this to work. Let's just grab 5 of those. So we're just going to grab 5 functions that I don't want to call it liquidation. I want to call it liquidate. That at least start with liquidate, and then we will go from there. We'll see if we can actually get these and get this to run and work. So none type object is not callable. I'm going to guess that's because this is not a real thing. With name, maybe let's try the plural one. So let's try liquidate. Exact 5. Okay, none type object is not callable. I think, I swear I've used this prefix function before, but it's not it doesn't look like it's working right now. So maybe that's why it's not in the documentation. Probably because it's a little bit buggy or it's not supported anymore. So we're just going to do liquidate. We're going to do liquidate dot exec. Let's see if we can get some liquidate functions. And here we go. So this is cool. I can see, okay, so we've got iFarming pool. So just some interfaces here. We've got a liquidation function. Did we already find a match? So underlying asset, safe transfer to the account, final amount to receive. That'd be funny if literally the first real contract here. So let's see. Let's just have a look at what's going on. And I really love that it gives you, the whole function to look at right here. Yeah, it makes it very nice to actually be able to like find this, dig a little deeper right in the UI here. So that's very cool. Okay, so let's have a look. Okay, so I'm seeing a number of transfers. Insurance fund, cool. That's going to be fine. This one I'm interested in, to the account. Who's the account in this? Yeah, so we're liquidating the account. Okay, so this is probably going to be an issue. So this liquidation function, you take in an account. So an account has a position. I don't even know what the hell this protocol is. But just looking at this, I don't know, borrow lending, perpetuals, whatever it is, you have some kind of account. And if that account just so happens to be blacklisted for this underlying asset address, so let's say this was USDT or it was USDC, and then you attempted to transfer to the account this final amount to receive, which is, I assume, let's see, where is this? Actual amount to receive dot sub penalty, right? So the actual amount to receive is, remove liquidity for, okay. So yeah, you get your liquidity back minus the penalty, and then they're going to send this to you. So really the trick would be probably getting that liquidity in for the blacklisted account. A lot of times that's where the complexity might be. For GMX v2, it was pretty trivial to get USDC credited for that account because anybody could send it and then it would get credited for that account. But depending on the system, you just have to be able to get USDC into the system credited for this account that just so happens to be blacklisted for USDC. And then if you wanted to liquidate this account, while there would be a final amount to receive, you wouldn't be able to do it. It would just revert right here. So literally right there, I haven't even finished writing the query, so it actually is good. We've just looked at the very first liquidation function, and it potentially has this issue. Of course, I'd have to look at the protocol in its entirety to see if you could actually get USDC credited for this account. Pretty sure there'd be some way. I'm just hoping that there would be some way, but usually there is some way. Depends on the protocol. But so that's very cool. We can already see the power of what this tool gives us to search every single verified contract. And I mean, I only grabbed 5 of them and we already found this. So very cool. Very cool. So the next thing I want to do is we want to actually find specifically liquidation functions that have transfers like this one does. So, and you can do that. So I can filter down to the instructions. So this will give me, what's happening inside of a function. And I want to find with called function name. So this method here, this method here. And then by the way, a little QA on the docs. I think this one is also a little bit different from what's in the docs. So maybe this is something we're just giving live QA while I'm here. Where is it? Under the instructions. Yeah, in the instructions here it says with call e function name. Little bit of a little bit misleading. I think it's with called function name. So I think they probably updated the syntax here, but then just in the documentation it hasn't been updated yet. So that's a low finding for you. Sorry, of course I'm going to audit this this web app in the documentation. But anyways, with called function name. So here's the thing. I could put transfer here, but then, for example, we would have missed this. because this is safe transfer. So let's see. I believe there's one where we can do with one of, so here's the thing, with one of callee function names, I don't think that function exists. So let's see, with one of callee function names, and then I presume you'd be able to provide transfer and safe transfer. And then let's see exec5, and then let me just make sure I spelled that right. Cool. Yes. So this should let us do either, one of those. So you should be getting liquidation functions that only have those calls. But yeah, I think I did try this out, this function, and I don't think it exists. I also tried this. So just like the other one. Not sure if this version exists. No, it doesn't. So let's see. We will try dot with. Yeah, we just have to do the one. So I'm just going to put transfer. Yeah, so I guess we'll just try transfer for now. We could switch it to safe transfer and look at those. So obviously, I think when more of these functions get added and give you more power to filter in certain specific ways, this tool will just become more and more powerful because all of the data is already there. It's really just about now how can we get the specific ways to parse through it in all the different ways that we want to as security researchers, find all those niche scenarios. So this thing will only get more powerful and more powerful as they continue to add and improve I guess really like the ORM that sits on top of all of this data that they've indexed. So okay, cool. So we've got with called function name transfer. So we're going to see functions now that are called liquidate that have a transfer call inside of them, which is pretty cool that I'm able to, do this and specify this. Like, I don't know, there might have been some pre-existing tools that allowed you to do this, but I'm not familiar with them. So this is pretty cool. This is, at least to me, this is the first time that we're able to do this, at least as, easily as this is allowing us to do it. So we've got a liquidate function here, and then I see, so another nice thing here, I'm actually going to zoom out. I hope that's not too small, but I'm unable, I will say I'm unable to move this, the thing that's a split in the middle. I can't move it to the left. It would be nice if I could like slide this over because there's time when you're interested in writing the query, and then there's time when you're interested in reading the results of the query. It would be nice to be able to slide that midpoint around because I don't care about reading the right hand of the screen when I'm writing the query, and I don't care about writing it when I'm reading this stuff. Another thing that would be nice is, and I don't know if this is already, it's probably hidden somewhere that I'm not aware of. It'd be nice to be able to download this in like a JSON format or something. That would be cool. Or maybe like I don't know if a CSV would be good, but some kind of file format, probably JSON somehow. These would be kind of ugly as strings, but yes. Anyways, so they've got it's weird. I wanna zoom out, but I also want to zoom in on this. I hope it's not too small, but I'll zoom in for you. Okay, so interesting thing here that I think is also great is we've got the whole function here, but then also it zooms in on, hey, here's what the exact line is that was basically flagged. So for this instruction, we got the transfer. And actually it's worth noting that technically no longer are we filtering for functions. So technically this shouldn't be called suspect functions. It should be called suspect instructions because these are instructions that occur inside of a liquidate function that have the property of having the name of transfer, but whatever, I'm not going to change the thing there. But yeah, so we've got this specific line here, and that's a substring of the entire function, singular line out of that function. And this one is the first one, which is right here. Yes, so they're referring to this one right here as what got flagged. And I assume we'll see the same function for this second transfer. Yeah, so the second transfer here that's listed is right here. So they're flagging every single instance of this instruction, which again is why these are, I'll just rewrite it. These are not functions. These are instances of instructions. And then another thing, as I'm sort of writing this right now is, I don't know if it's me, could definitely be me, but the web app interface to type sometimes seems a little slow, a little bit laggy. But of course, it's a beta, so you know that's how it's going to be. Okay, but anyway, do we have a vulnerability here? Let's see. So we've got the token vault. Well, okay, so first of all, we're calling the token vault. I would have to see what the token vault does with this, and if this collateral could be USDC or USDT or something with a blacklist. They're transferring address this to, and the to address is, let's see, who's the to address? Oh, that's another thing that would be useful is like if I could have a grep inside of these, if I just want to look at specific things within each of these functions, that would be kind of cool, like a dedicated way to search parse these, just kind of on the fly. Let's see, what was I looking at? The two, I don't know where the two is. Okay, so I see here the two is just a parameter being passed in. I see. Okay, so this is that one is specified by the whoever the liquidator is, so that's fine. The liquidator shouldn't be DOSing themselves, so that is fine. And then the borrow share is going from the message sender to this. So, the liquidator is covering that. Okay, so this one is kosher. No issues found here. Let us continue to, well, okay, so actually, it'd be great if we could improve the query from here. But from, I guess, the little time that I've spent with this, I actually don't see a way to be able to specifically require that transfer is being called like on USDC itself. It'd be great if we would be able to specify like, hey, we want to see only the transfer calls that are coming from USDC itself, like literally be able to search the address that is being called ultimately, and then only filter for those instances where it's calling USDC. Otherwise, you could also just search for variables that are titled like named USDC. I think that would be possible. I know you can definitely filter for variables. You can filter for variables that have a certain name, like they have here. But for whatever reason, filtering for variables was taking extraordinarily long for me. You can see actually here I was actually messing around with this, and the query is still running. So yeah, I don't know why, but that was taking long. And then also I think, man, I think what would you would have to do is you'd have to filter variables, and then you'd have to jump up to the function level, which I do think they would allow you to do. So I do think it would be possible that way. Right now, for whatever reason, taking a little long. But with that being said, I think this is the best, at least that I'm willing to put into this query at this time. Just getting liquidate functions that call transfer. So what we can do is we can just skim some of these. So this is looking similar contract, similar function. This one is a cauldron. So I recognize this code. This is definitely a cauldron. So what I'm going to do is I've added an offset now. So I can do 5, 5. That's going to split those first 5 ones, and then we're going to look at the next 5 ones. So let's have a look. Made the query. Still looking at that same contract. Got this is interesting, although it's a WETH transfer, so no blacklist there. LP token transfer, no blacklist there. Bento box transfer. So we're looking at a cauldron liquidation, it looks like. And yeah, of course, bento box transfers are not going to allow you to do that, so that's fine. Shout out Abracadabra Money. Yeah, let's see. This is another, yeah, same thing with the bento box. So let's skip ahead another 10 so that we'll splice off those 5, and I'm actually going to switch it to increments of 10. So we'll look at 10 more functions here. So let's have a look. Liquidate, same contract. There's a few transfer calls here. So we'll be getting through all of those. Again, liquidator. Okay, so here's an instance where we liquidate some collateral asset. Now, we're transferring it to the message sender. So the message sender is the liquidator. They shouldn't be blacklisted, right? And if they are blacklisted, then somebody else can liquidate it. So that's not an issue. Again, more Kashi stuff, Kashi stuff, Kashi stuff, Kashi stuff, Kashi stuff. Sushi swap goblin. Okay, again, the same, transferring to the message sender as a reward. So let's go, boom. Actually, we've looked at the first 20 now, so let's go to the next 10. Let's see. We're trying to get our vulnerability here. Okay, Kashi, 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 Liquidator. What is this? Here's our transfer. You can see collateral asset, transfer to the message sender. Kashi, 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 Kashi. It's just got like a ton of transfers in it. It's a bunch of sushi swap, another cauldron, lever v1. Let's have a look. What's the line here? The buy token dot transfer to the lick marker. So let's have a look. What is going on here? So we're transferring to the lick marker. So a couple of questions we need to ask ourselves. First of all, can the buy token be USDC or USDT or some token that has a blacklist? For our purposes, I'm going to assume yes. And then is the lick marker, is that able to be an address that could be blacklisted by one of these tokens? So let's have a look. It is. So let's see. Trade. Let's see who. I mean, I guess. And this is where this is taking place. So it can't be address 0. On the trade, this is just something stored in. Okay, so I have an idea of probably what's happening here is we've got these active trades, which are really just positions. I don't know what this protocol would be. Some kind of leveraged something. Maybe it's a perpetuals. I don't know. But whoever, it seems like you've got to flag positions to be liquidated. I don't know where that requirement is, but there's some address that will actually mark it as being liquidatable. And that person's ultimately going to get a reward. They're going to get some of these buy tokens. They're going to get half of this penalty. Okay, so this is, I think we got them. So we got half of the penalty going to the person who actually, executes this liquidate transaction, and then half of it's going to the liquidate marker. So whoever liquidates or marks this position or this trade as being liquidatable could be blacklisted for USDC, or in other words, whatever the buy token is. So in that case, if I am a somebody who marks it, and then I'm blacklisted for that token specifically, and I could do this for my own trade so that it cannot be liquidated, then the liquidation just reverts, and I essentially have a position that cannot be liquidated and will ultimately just accrue a ton of bad debt for the protocol. So here's a significant issue, a legit issue. So we found this twice. We found 2 occurrences of this already, and we've just we just started using this thing. So I think that's pretty cool. It's too bad, of course, that this is on testnet. So I think what we'll do is we'll have a follow-up video where, once, if we're able to get Ethereum mainnet working, we'll go ahead and we'll try out this query, and then we'll try out a few others that I have in mind, a few other cool things that I want to look into. But overall, I think obviously it's still in beta, and maybe there's a little bit of a discrepancy in the documentation. Maybe there's a little bit of bugs. Maybe some of the queries take long. Sure, that's a beta, but I think that fundamentally what this is, and the idea of what we're able to do with this is actually somewhat profound. Not incredibly profound, but somewhat. I think it's really cool. I think what this will add in terms of having almost a deflationary effect on, like, we can take one idea of, like, one security researcher can take one idea of a vulnerability that they have, or something that they find in an audit, and they can immediately go and apply that across the entire ecosystem of, ultimately in the future, every single EVM chain, every single contract on all of those chains, and really the only thing stopping that specific security researcher from saving the entire industry, the entire deployed set of smart contracts from that bug, is just the granularity and the versatility of the query layer that they're able to try to find that with, because we have all the data. that is all here. And we can basically grep, we can search all of the verified smart contracts. It just comes down to a matter of, can you express this bug or vulnerability in a query? And if you can, then every contract can be protected for the rest of time. I mean, you could do a ton of stuff with this. You could hook up, some kind of MEV like protection network on top of this. And so as soon as one exploit happens here, you can go ahead and, have a query made. Maybe there's even some crazy AI stuff going on. Make a query, copy that, um, find all the affected contracts, find a way to white hat them or at least alert the teams, um, and be able to protect that. So I think that this is really something that will finally be able to provide, a standard of smart contract security across the board, for certain vulnerabilities that can be applied across code bases. Now, of course, this doesn't eliminate all vulnerabilities. In fact, probably sadly, the majority of bugs that occur in a code base are going to be specific to that code base and specific to some of the logic there. But a great deal of it will be able to be abstracted out, and just addressed across the board, which I think is really, really something excellent for the EVM security community. And last of all, I think this is a great offer to security researchers specifically because, um, I mean, I don't know if you were watching, but we just found like two vulnerabilities that potentially, I mean, of course, we'd have to go and confirm those, but potentially those could be two high vulnerabilities that we've just found in a handful of minutes here, just after, I've spent some time to figure out how the tool works, but this was literally us going through and finding these, um, for the first time. So I think that is a great offer to, hey, if you're a security researcher and you have ideas for exploits, I would get on this thing. And of course, we're on the Covin testnet, but if we would switch to Ethereum, if that would work, it's not right now. If that would work, like, we'd be firing off freaking submissions, dude. Like, this is kind of a gold rush to be one of the first security researchers to go and make queries on this thing. And you had better believe that I'm going to make a follow-up episode where we actually go on Ethereum mainnet and we try to find some juicy stuff. And I'll share that with you guys. But with all that said, I think this is really, a big leap forward in terms of the security tooling that is, publicly available. Again, this is totally available. You can go and use this right now. You can come and use it on Covin testnet. You can start getting used to it, start having a look at the documentation, start using it yourself, sign up. They've also got some bug bounties here as well, because obviously it goes very hand in hand with a tool like this. But yeah, very cool how all of this is, freely available. You can start using the tool now. I think that, as we start to add in some networks that have, real funds sitting on them, it's going to get pretty crazy. So, and again, well, I don't know if I said this, but uh, they did not pay me to make this video or anything like that. I just thought that this is actually legitimately a really cool piece of software for the community, for the Web3 security community. And yeah, the potential here is immense. And I think that the potential for you as a security researcher to go and find some stuff and make, a lot of money from disclosures is pretty high as well. So that's all I'm going to say. I'm going to stop talking so much. Moral of the story, Ladder's a cool thing. You could probably make some money with it. I would start learning how to use it just to, be able to find cool stuff. But other than that, hope you guys enjoyed. We're going to do a follow-up episode, try and find some stuff on Ethereum mainnet, and I'll see you in the next one.